Hello, so today I'm going to talk a little bit about odds and probability distribution. Now, when we talk about odds, there's a definition of which that we can say, like, how do we find the odds of a particular event? So we say that the odds is determined by the following. You take the probability of an event divided by the probability of an event that does not occur. But because we can actually say, for example, that we know that the probability of an event E can be divided by the complement. So we have that the probability of E not occurring is going to be 1 minus the probability that E does not, or yeah, 1 minus the probability of E. Now, this of course is provided that the probability of E complement is not equal to 0. Now, another way that we can find a probability is that we can look at the formula for each of the two. So, for example, if we know that the odds of in favor of an event is A to B, then that tells us that the probability in favor of the event occurring is equal to A divided by A plus B. But if this is the case, then that means that you also have that the probability of the event not occurring is actually going to be B divided by A plus B. So this gives us the odds in favor, and we'll just go ahead and write that this is in favor. Okay, so one way that we can look at this is that, for example, if we happen to know that the probability of rolling a 3, if we roll a die, is 1 out of 6, then that means that the odds in favor, so we would put that we have that the odds in favor are 1 divided by 6 over the complement that you do not roll a 3, which is just 5, 6. Now, notice that this gives us 1 over 5. Now, strangely enough, the odds in favor can be written as follows: 1 to 5. So we have that the odds in favor of rolling a 3 is going to be just 1 to 5. Now, I would recommend that you try different examples, like for example, rolling, flipping a coin, or perhaps like the odds in favor of a child being born as a boy or a girl, then it's roughly the same thing. So let's say that, just to do one more example, that we look at the odds in favor of a racehorse. Racehorse. Okay, so let's say that we look at the odds in favor of a racehorse. So we have that the odds are 3 to 7. So we want to know what is the probability that the racehorse will win the race. Okay, so to do this, we just simply just say, well, we have that the probability of winning is going to be the odds in favor, so that's going to be 3 divided by 3 plus 7, which is 3 over 10. So we have that this is going to give us a 30% chance that the racehorse is going to win, which would say that that would be a bit of a risky wager. Now, one of the last topics that I would like to look at is the probability distribution. So, whenever we look at the probability distribution, well, the probability distribution is more or less like just thinking of all of the different outcomes that we can have in an experiment and writing them like so. So let's say that we have a sample space and we have that there's the possible outcomes x1, x2, x3, and so on. Well, these are n possible events, and respectively, we'll say that the probability of the xi is equal to p sub I. Now, I is an integer from 1 to n. So we just have to be sure that we understand that p1 is the probability of event or outcome x1 and so on. The next thing that we would have to notate is that the probability of a single event or outcome has to be between 0 and 1 inclusive. So that tells us that if it's negative or 2, then it cannot be probability distribution. So, and finally, we have that if we add up all of the probabilities within the sample space, like P1, P2, P3, not P, but P, this all has to add up to 1. Okay, now in this case, like we can look at a example of a probability distribution. So one of the easiest experiments that we can look at is when a coin is flipped 3 times. Now here we're just going to say that the number of times tails lands is counted. Now, this means that we have to come up with the probability distribution as it relates to a coin experiment when the number of tails is counted. So what that means is that as we look at our sample space, we have to consider, well, the least or the lowest common outcome in this case is that it doesn't land at all, which is 0, followed by 1, followed by 2, followed by 3. Now, the next step would be that you would have to find the probability, respectively, of each of those. Now, one way that we can figure this out is by saying, well, if we look at the total outcomes overall between, like, saying if we look at heads, heads, heads versus tails, 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 or even just heads, tails, tails, well, you're going to do this so many times that that's going to give you the total possible outcomes. So this is equivalent to the 0, the 1, the 2, and the 3, but just counting the number of times that the that tails comes up. So one way that we can do this is, for example, we can actually just think of, well, there are two options essentially. You have that for every toss, there's two options multiplied by another two options for the second toss, multiplied by another two options, and those options are heads and tails, which means that you have 8 outcomes. Okay, well, that means that we can actually furthermore figure out that if we're looking at the probability of 0, well, the probability of 0 is equivalent to how many outcomes might have no tails at all. Well, I already have it pulled up right here. That's heads, heads, heads. But that's only just one way of finding that. So one way out of 8, which means that the probability is equal to 0.125. Now, furthermore, if we go ahead and we look at the probability of 1 tails, well, the probability of 1 tails is going to be tails, heads, heads, and then furthermore, you have that that's going to be heads, tails, heads, and then heads, tails, not heads, tails, but heads, heads. Let me see if I can do this again. Um, yeah, that's going to be actually, okay, let me just get rid of this. Okay, so we also have that there would be heads, uh, heads, and then followed by tails. So what that is that's 3 possible outcomes out of 8, which gives us 0.375. Now we can do this again furthermore with like 2 tails, where we have that that's going to be tails, tails, heads, but that's the same thing if we were looking at 1 tails versus 2, so we're just kind of moving them around. So if that's the case, then you have that that's 3 out of 8, which is 0.375. So we get the same exact thing. Now, the last but not least outcome is whenever we have the probability of 3, which is equal to, well, that's just really one outcome. So that's 1 out of 8. What is that one outcome? That outcome is tails, tails, tails. And let me just put heads, tails, tails, and then tails, heads, tails. So this tells us that this is going to be, so we have that this is going to be 0.125. Okay, so that gives us the last one. So that means that now you can actually construct your table as follows. So just remember what they were. They're these right here. So if we go ahead and we write out our table, and let's say that we have the probability of xi, then we have the probability of xi. So let's go ahead and just write out each of these. So we have 0, we have 1, we have 2, and then we have 3. Now this was 0.125, this was 0.375, 0.375, and then we have 0.125. Okay, so what this means is that essentially we have our complete table, and we can demonstrate, for example, on how can we find specific probabilities. So for example, like if I have the probability of at least 1 tails? Well, according to my table, I can find that by just saying that this is equal to the probability of 1 plus the probability of 2 plus the probability of 3, and then that's going to give me the following. It's going to give me that we're just going to add up 0.375 plus 0.375 plus 0.125. But that's just going to equal to 0.875. Okay, so we can actually approach this problem a bit differently though. For example, so what if I just said that the probability was that instead of using the whole remaining table, we can just say, well, I know that it adds up to 1, and I'm just going to subtract the probability that there are no tails. So that's going to be 1 minus 0.125, which is actually equal to the exact same thing, 0.875. So you kind of see how like you can use the probability distribution table to your advantage, and then you come up with like the different types of tricks. Now, not to really make it more complicated, but one other way that you could have done this is just to say 1 minus the probability that it is tails, or no, the probability that it is heads. So that's going to be 1/2, and then you just raise it to the 10. And what that does is it, oh,